Well, hi, hello, my dear students. Welcome to my video lecture class. Right up to now, I uploaded video lectures on the topic Newton's laws of motion. In this topic, I explain Newton's first law, Newton's second law, Newton's third law, and their applications, change in linear momentum and its applications, impulse concept. These are all I explained in previous lectures. Please go through that lectures for better understanding. Today I am going to discuss a newer application related with the law of conservation of momentum. Law of conservation of momentum. A newer application related with the law of conservation of momentum. So today we discuss based upon application number 4. So today we discuss application number 4. Let us consider a boat of mass capital M, which is at rest, initially at rest on water. If person has mass small m, and he walks on boat some distance. He walks on boat and cover some distance and moves some distance, yes, then boat will floats on water and moves backward with the distance d. Then find backward distance covered by boat. So that is the question here. Observe carefully. Let us consider a boat. So I'll consider this as some boat. Okay. So this I consider as a boat. Let us consider a boat. A boat of mass capital M. So which is placed on water, which is initially at rest, which is placed on water. So which is placed on water. The person stands on boat and he walks on boat and he covers a distance, yes. He covers a distance, yes. Meters. Okay. So the boy of a mass here, boy moves forward and covered distance, yes. boat moves backward, boat moves backward, and covered distance d. Okay, so now according to law of conservation of momentum, according to law of conservation of momentum, okay, momentum of boy is equal to momentum of boat, momentum of boy along with boy. Boat along with the boy moves backward and covered distance d. So momentum of boy. So for example, mass of boy is small m, and here distance, let us consider small v, velocity of and here mass of boat is capital M, and mass of boy is small m. Momentum of boat along with the boy. Momentum means mass into velocity. Mass of boy, velocity of boy. Mass of boat along with the boy into velocity means capital V. So from this, small m into, here velocity means distance by time. He covered distance is S and T. Okay, next here m into small m. Here velocity means d, distance covered is d by t. So boat covered distance is d here already given. So water moves backward with the distance d. Is it or not? So boat covered distance is already given, distance is d, and it covered distance is s. Okay, so already we got here from this this t going to be cancelled. Finally, what we got here, m into s is equal to capital M into small m into d. What do you want here? So here we want so d, backward distance, small m into s by capital M plus small. Okay, so that we need to find backward distance covered by boat. That is what? Backward distance covered by boat. Backward distance covered by boat. Backward distance covered by boat. What is backward distance covered by boat here? So here backward distance covered by boat is a d is equal to m into s by capital M plus small m. Capital M plus small m. Okay. So here small m means mass of boy. So I would like to write here. So one by one. Here small m means mass of boy, capital M means mass of boat. Next S means forward distance covered by boy. Next, D means backward distance covered by boat along with boy. Next, T, time taken by boy and boat to travel certain distance. So these are the parameters we are using here. So this is about application number 4. This is also solved based upon law of conservation of momentum. Next, I'm going to discuss application number 5. Application number 5. Okay, now I am going to discuss application number 5. So observe carefully. Application number 5. Right. Bomb is exploded into 3 pieces. So few minutes back, in last lecture, I explained bomb is explodes into 2 pieces. Now in this lecture, bomb is explodes into 3 pieces. Let us consider a bomb. This is a bomb. Okay, so this bomb having mass capital M. This is explodes into 3 pieces. This is explode into 3 pieces. Explodes into 3 pieces. So this is 1, 2, 3. 3 pieces. One piece having mass M, M1, 2, M2. This is the third piece having mass M3. Bomb explodes into 3 pieces. M1, M2, M3. Masses of each piece. And velocity of each piece. V1 bar, V2 bar, V3 bar. And momentum of each piece. P1 bar, P2 bar, P3 bar. Okay. So this is a mass. Here velocity, here momentum. Okay, momentum of each piece, P1 bar, P2 bar, P3 bar. Okay, so P1 bar, P2 bar, P3 bar. Okay, so initially bomb at rest. So this is very important. So initially, if a bomb is at rest, it explodes into 3 pieces, each piece having mass M1, M2, M3, velocity V1 bar, V2 bar, V3 bar, and momentum P1 bar, P2 bar, P3 bar. So now, according to law of conservation of momentum, P1 bar plus P2 bar plus P3 bar is equal to 0. So this is very, very important. P1 bar plus P2 bar plus P3 bar is equal to 0. From this, P3 bar is equal to P1 bar plus P1 minus P1 bar minus P2 bar. So from this, P3 bar is equal to minus of P1 bar plus P2 bar. P1 bar plus P2 bar. So this is very important. P1 bar plus P2 bar. So P3 bar is equal to P1 bar plus P2 bar. So from this, here observe carefully. That means, observe carefully, P3 bar is equal to minus P1 bar plus P2 bar here. So from this, so this I consider as a P1 bar, this I consider as a P2 bar. After exclusion, two parts make an angle. Angle between the two parts is theta, and this is the third part I consider as a P3 bar. Okay, so P3 bar. So here observe carefully. So the direction of third piece is opposite to the resultant of first resultant direction of first and second piece. So the direction of third piece is opposite to the resultant direction of first and second piece. What is resultant direction of first and second piece? This is the resultant direction. This is the resultant direction. This is the resultant direction of first and second piece. So this is a PR bar. So resultant direction of first and second piece. Okay, resultant direction of first and second piece. PR is equal to here. PR bar is equal to resultant direction of first and second piece. So this is observe carefully. That means the magnitude of third piece is equal to sum of the magnitude of first and second piece. Sum of the magnitude of first and second piece, but in opposite direction. Magnitude of third piece momentum is equal to magnitude of resultant of first and second piece momentum. So this is very important. So this is important, and this line is very important. Observe carefully here. The direction of third piece is opposite to the direction of resultant of first and second piece. So this is the resultant direction. Resultant direction opposite to the resultant of first and second piece. And the magnitude of third piece momentum is equal to magnitude of resultant of first and second piece momentum. Here. So now observe carefully here. From this we concluded so this I consider as angle between this two is theta, angle here is alpha, and this angle we got pi minus alpha. Okay, theta is angle between P1 bar and P2 bar. Okay, alpha is angle between PR bar and P1 bar. So pi minus alpha is angle between P3 bar and P1 bar. Okay, P3 bar and P1 bar. Here we know minus P, observe carefully, P3 bar is equal to minus of P1 bar plus P2 bar. So apply magnitude on both sides. That means magnitude of P3 bar is equal to magnitude of minus of P1 bar plus P2 bar. So that means P3 is equal to square root of P1 square plus P2 square plus 2P1 P2 cos theta. So this is very important. If one bomb is exploded into three pieces, momentum of third piece is equal to, so this is formula, momentum of third piece, momentum of third piece. Here alpha is equal to, here tan alpha is equal to, P2 sin theta by P1. So here tan alpha is equal to, so alpha is equal to direction. So alpha is equal to, tan alpha is equal to P2 sin theta by P1 plus P2 cos theta. P1 plus P2 cos theta. So this is a very important. P3 is equal to, here theta is angle between, alpha P1 bar and P2 bar, and alpha is angle between PR bar and P1 bar. Pi minus alpha is angle between P3 bar and P1 bar. So P3 is equal to my square root of P1 square plus P2 square plus 2P1 P2 cos theta. 2P1 P2 cos theta. So this is application number 5. So whether one bomb is exploded into two pieces, momentum of one piece is equal to momentum of second piece. If one bomb is exploded into three pieces, momentum of third piece is equal to square root of P1 square plus P2 square plus 2P1 P2 cos theta. So this is about today's lecture. So again I'll explain some more application and some more detailed points about the law of conservation of momentum and further lectures. So I hope you are all understood this lecture. So while watching lecture, if you will get any doubt, please mention in comment box. Thank you for encouraging me. Thank you for watching my lectures. So again, I'll come back with new concepts and new formulas. Thank you so much.